Now today in this video, in this class, we will study the applications of electrolysis. In the previous classes we have already studied different factors and different examples. Now in our daily life the electrolysis is used for different purpose. So this time we have to study application of electrolysis. The most common application is the electroplating. Electroplating. As the name suggests, electro means electricity, current, plating means depositing, making a layer over another substance. So it is the process of depositing thin layer of superior metal. Superior metals means less reactive, because they will not take part in reaction, they will not be affected easily. Superior metal over inferior metal that is more reactive, that is which is easily affected, easily corroded, more reactive. By electrolysis is known as electroplating. Now what is the purpose of electroplating? Why is this process utilized or used? Now there are two main purposes of it. First, that is to prevent base metal. Base metal means the metal article from corrosion. That is rusting. Second, to enhance appearance or beauty of the article, metallic article. It is simply used, we know that cheaper ornaments are electroplated with gold and silver. When a very thin layer of gold or silver is deposited over cheaper ornaments, they are not corroded and they appears like silver or gold. 1 point. Second, the iron articles are electroplated by nickel or zinc to prevent it from rusting. Now, so this is called electroplating. Now, in order to arrange the setup for electroplating, we must know some conditions required for electroplating. How will you arrange the setup? The first important thing, the article to be electroplated should be placed at cathode, because the metal is discharged at cathode. Metallic ion is discharged at cathode, so metal will be deposited at cathode. Next, the metal to be deposited should be placed at anode. Because we have seen a takeable electrode, that is metal from anode is transferred to the cathode. So this can be used here. Third, the electrolyte should be the salt solution, a soluble salt of metal to be deposited. And last condition, these are the three conditions, and the last condition, low direct current, that is DC. Low means for a small current. We will not take excess of current. Low direct current is passed over long time for a smooth coating. So these are the four essential conditions required for electroplating. Now, suppose we take one example here. Take one example, that is now example number 1. Electroplating of a spoon by silver. Now, according to the condition, the question is asked. Suppose this is the question that a spoon has to be electroplated by silver. Draw the diagram for the setup or for the arrangement. Now you see here that according to the conditions discussed, first of all, the spoon, that is the article to be electroplated, is placed at cathode. The metal to be deposited is placed at anode. And now the circuit is completed here. Now we see that we should have the electrolyte of the salt solution of silver. Then we take here sodium argentocyanide solution, that is NaAgCN whole twice. Now silver nitrate is a strong electrolyte, but it is not used. The question is asked because it is very strong electrolyte and rapid discharge of silver ion does not allow a smooth coating. So we will not use silver nitrate, but we will use sodium argentocyanide or potassium argentocyanide. So now you see, that is the electrolytes. So just you see, at cathode there is the article to be electroplated, at anode the metal to be deposited, that is silver rod, a spoon, and now the electrolytes. NaAgCN whole twice. It ionizes, it dissociates to give us Na plus, Ag plus, plus Cn, that is 2Cn minus. At the same time, water ionizes to give H plus and OH minus ion at cathode. Now first of all, while writing or studying the electrolysis process, we must see the nature of electrode. This electrode is attackable. So just remember, we are given electroplating by silver. So at cathode silver should be discharged. And as a here you can also see that if we take the electrochemical series, the silver ion is lower in position. Although even not in that case also, since there is attackable electrode, so this metallic ion will be discharged at the cathode, means the silver will be deposited over the cathode here. And at the same time, at anode, now again you see, since there is attackable electrode, how is it? The anode is silver and the electrolyte also contain silver, so attackable. And it is easier to write an electrode reaction for attackable electrode. Just write its opposite, that is silver loses its one electron and change into Ag plus. So from here silver ion enters into the electrolyte and here it is deposited. Now, clear student? So, we can easily show here this one. This is a attackable electrode. What do you see here? That gradually the mass of anode decreases, the mass of anode decreases and mass of cathode increases. So this is the first example. Now suppose student, suppose as another example, if you have to electroplate with nickel, then what will be the changes made here? If we have to electroplate with nickel, then what should be changes made? First of all, you will change nickel at anode, the metal to be deposited is taken at anode, and the electrolyte will be also changed, nickel sulfate solution. As a result, at cathode, we see here that suppose we have NiSO4 gives Ni2 plus SO42 minus and H2O, H plus and OH minus. At cathode, Ni2 plus 2 electron gives Ni, and at anode, Ni minus 2 electron gives Ni2 plus. So just you see that this is a simple method of writing the electrode reaction for attackable electrode. So in this way, the metal article is deposited over by superior metal, or that is less reactive metal, to prevent it from rusting, prevent it from corrosion, or to enhance its appearance or beauty. Now, a student, the second example application is electro refining. Electro refining, or we say purification of metal by electrolysis. This method is used industrially in extraction of metals. That is, when metal is extracted from its ore, then it is required to be refined. The metals like copper, zinc, etc. are refined by electrolysis. So here we have an example, refining of, or that is we directly write electro refining of copper. Now again we will have to arrange the setup. How is it arranged? Again, since we have to refine, then in that case, whenever we have to refine, then thin stripe of pure metal, thin stripe of pure copper is taken at the cathode. The metal to be refined in pure form is taken at cathode, and thick cylinder of impure metal, thick cylinder of impure metal is taken at anode. Circuit is completed, and then we see that the electrolyte will be the salt solution of that metal. This is a simple setup. Now write electrolytic reaction, electrolytes. CuSO4 gives us Cu2 plus SO42 minus ion, H2O because it is aqueous solution, H plus and OH minus ion. Now the reactions. At cathode, again you see cupric ion will be discharged, no problem. Copper metal is deposited or deposited over this, and at the same time you see here we have attackable electrode because the salt solution is of copper and the anode is made up of copper. So from here we see that Cu2 plus ion from anode enters into electrolyte and then deposited here. So attackable electrode. So just you see that copper metal from anode is transferred to the cathode. Now one more thing. Under the anode, here the impurities are settled. That is called anode mud. Anode mud or slime. The impurities are pure metal is discharged and impurities are deposited at the bottom. Now the question is asked that what is the significance of electro refining of copper? Electro refining of copper. First, pure copper is obtained, and second, from anode mud the more valuable metal like gold and silver are recovered. So just you see that is there. This is another importance of this method. One more thing, we have studied electroplating, electrorefining. Question is asked, that is, write two applications of electrolysis in which anode decreases in mass and cathode increases in mass. Then it will be electroplating and electrorefining. Clear, student? Students, the next application of electrolysis is electrometallurgy. Electrometallurgy, that is extraction of metals by electrolytic reduction of their molten oxide or chloride ore. In the first example of the chapter, we had studied about the electrolysis of molten sodium chloride. That is the chloride. And here last one is studied as electrolysis of the oxide. Example, extraction of aluminium from Al2O3, that is also known as alumina. Now this is the important topic which will be studied again in metallurgy, extraction of metals, extraction of aluminium. The same topic has to be studied here. In this process where aluminium has to be extracted, as we know that metals from potassium to aluminium are highly reactive, so they cannot be extracted by simple reducing agents. So we have to use electrolysis process. Now here we see the process is, the name of the process which will be taken in the metallurgy mainly Hall-Herold's process, and the apparatus That is, so we take here Hall Herold's process now only. Now since it is an industrial process, so a huge or big iron steel tank is taken and it is lined, means coated from inside by gas carbon, that is called carbon coated, and at the bottom here the exit for aluminium. Now the series of carbon rods are suspended with the help of clamp and rod. That is, here this will be the anode, here this is the anode, cathode, this is anode. It is made up of graphite, and this is a steel tank lined with carbon. So if it is asked, name the element used as the electrode, cathode and anode, then both of them is carbon. Now then we have to use electrolyte. The electrolyte is not only this one, but it is the mixture of molten Al2O3 plus Na3AlF6 plus CaF2. That is, this mixture is used as electrolyte, not simply one, single one. So what are the electrolytes? First of all, alumina, that is Al2O3 gives us 2Al3 plus 3O2 minus. Now again there is another one, that is called cryolite, that is Na3AlF6, that is also known as trisodium aluminium hexafluoride. It gives 3Na plus Al3 plus 6F minus, and the third one is fluorspar, that is CaF2. It gives Ca2 plus 2F minus. So these are the three types of electrolytes. Now what are the reactions taking place at cathode? You see that there are three types of electrolytes, that is cations, and in the electrochemical series Al3 plus will be lower in position, so it is discharged first. Al3 plus 3 electrons gives Al, means along the wall of the vessel, wall of the container, tank, aluminium will be discharged, and which will be taken out in molten state from the bottom. So along the wall, since this is the industrial process, so there is a huge tank, so aluminium discharging at the walls will be settled down, and at the bottom it will be taken out, that is the metal. Now next, at anode, here there are two types of anions, fluoride and oxide. Again think for the next, that is the anion series of electrochemical series. Oxide is lower in position, so it is the oxide that is discharged here, and O plus O gives O2, hence at anode oxygen gas is released. Now this is a simple electrolysis, student. We have got the pure metal here, but there is some more questions related to it, like the first point. First point is here that the oxygen released at anode oxygen released at anode combines with carbon at high temperature to form CO2. So, gradually the anode is oxidized. Gradually, anode is oxidized, hence it is replaced. It is replaced periodically. Now, a student, since the process will be discontinued, so to make the process continuous, charcoal powder is sprinkled at the top. Charcoal powder is sprinkled here, that is charcoal powder that reacts with oxygen and prevents oxidation of anode, as well as they will also prevent loss of heat by convection and radiation, hence save electrical energy. So, to make the process continuous, we will use the same topic, same point. One more reasoning is asked here, students. That is, what is the role of cryolite and fluorspar? Role of cryolite and fluorspar. They bring the fusion temperature, that is melting point, fusion temperature of pure alumina from 2050 degrees Celsius to 950 degrees Celsius and save electrical energy. They also increase conductivity of electrolyte. So this will be studied in detail in metallurgy chapter again next time, but we have used the application of electrolysis in the process. So students, all of this is about electrolysis chapter. Now you will be able to answer if you will study it one by one in systematic way, relating one topic from the another. Now go through the exercise and practicing the examples. Now it is all over. If you like our teaching, then like it, share and subscribe our channel, as well as press bell icon to receive the latest videos. Thank you, student.